framework, doing a lot of extra work, actually having its very own model. Grails isn't really building on Spring as a natural extension of the Spring framework. It more sits on top and reuses the Spring framework underneath the covers, at least most of the time, letting you dive down, but basically running its own model on top. And that is great. So what we do in Spring Framework 4 has basically a number of those audiences and kind of stakeholders in mind. We are of course doing it for our traditional Spring Framework 4 audience. We're to serve as a foundation for Grails 3.0, which will be coming up next year. And we are already in talks and considerations for changes, rearrangements, new modes of processing that Grails 3 is going to pick up. Of course, a little bit later because Spring Framework 4.0 will go final this year. And we're trying to identify interesting middle ground. What about using Spring Framework and a Spring-based application architecture as people know it from Java, as it's commonly done in Java, but using Groovy as the choice of language? So there are quite a few interesting ways of how to use Groovy with Spring, and there's a little bit more extra work that we're doing now towards some of those. So much for an introduction. I'll be showing you some concrete things we're doing in a second. I should actually very briefly introduce myself. My name is Jürgen Höller. I'm running the show at Spring Framework, so I am the Spring Framework project lead, and I have been guiding it for more than 10 years now. And I work on Spring Framework 4.0 code level features as well. I own the Java 8 topic. I own the Groovy topic, so I am actually the one working on both the Java 8 features. I'll show you a little bit about Java 8, and the Groovy features seen in this presentation. Working on needs to be defined a little here. It says work in progress. The Java 8 related work has been largely completed and been released this week, earlier this week, a few days ago, in Spring Framework 4.0 and 1. So that part of the work in progress is largely done. Of course, it is tracking JDK milestones and so forth. There's still some remaining work. The Groovy-related work has been intensely discussed, but not actually started yet. That's an opportunity for you. If you have ideas, if you have design considerations of any kind, let us know. Let me know, let us know on our usual communication channels. We are early enough in doing this work that we can still set priorities or fine-tune the ways that we want to do things here. This work is then going to end up in M2, so the first time we're actually going to release some of this fresher, newer Groovy support in Spring Framework itself will be for the M2 in July. All right. We'll revisit some of those things anyway. So we're not going to go into a lot of detail on this one here. These are the Spring 3 component model themes. They're important as a context to keep in mind, because lots of the things that we've been doing in Spring 3 kind of define the Spring way of doing things these days. Annotation-based dependency injection, declarative caching, one of the more recent introductions. Of course, Spring MVC as we know it now. Spring MVC controllers, Spring MVC request mapping, handler methods and so forth. All of those things really came together in Spring Framework 3. That's like the past 4 years basically. We've been working on those things and really tightening up the model. Spring is a very concrete programming and configuration framework these days. So it has its ways, modern day ways, of designing components, implementing basically the components in the system, and its ways of configuring the runtime, the middleware around it. So that's really what we mean if we say a Spring Framework programming model or Spring-based application architectures. We mean applications really hanging on to those core component model features in Spring Framework 3, working very closely with them. Stylistically, I suppose you've seen this, right? I mean, and bear with me that this is Java code. So this is basically modern-day Spring component style. A component class, carefully named usually, carefully annotated with like stereotype annotations up here, dependency injection annotations, and declarative service annotations, such as transactions, caching, declarative scheduling, and async. There are quite a few of those. So that's basically modern-day Spring component design in a nutshell, right? And just if you imagine implementing such a class in Groovy, it may actually pretty much look the same. Just drop a few keywords, basically. This style of component design, this approach that Spring Fabric is promoting here, translates very nicely into Groovy. Not least of it all, of course, due to Groovy's very, the very mission behind Groovy, right? Basically being somewhat close to Java, appealing to having great annotation support. So all of those things really connect very well in combination with the core Spring programming model. In terms of configuration style, you may have seen some of this. That's a configuration class where traditional XML bean definitions are being replaced with factory methods, basically. Those factory methods building one bean at a time and connecting those. This works great in combination with any of the features in the actual. Also, any of those returned components from such a bean method, from such an add bean method, can of course use any of those annotations in here, so those dots connect really well. The configuration class model is not the only way, of course. People still use XML bean definitions, and we have in doing so. There's also component scanning that's worth a note here, and you may have seen this, not least of it all in Grails, where those things, those components are not being defined by factory methods here, where components like this are being auto-detected in the class path. The core Spring way of doing these things is to use the stereotype, this service stereotype up here, the stereotype model for identification purposes. We're basically searching the class path, trying to find annotated components that have add component, add service, add repository, add controller, one of the stereotypes following the type model at the top of the class. To register all of those in the class path and just as Spring managed beans and basically build your set of components through a class path scan. That's also quite common these days and works nicely in combination with these guys because configuration classes have a stereotype, can be auto-detected in the class path as well. It can be mixed and matched. A few beans created this way, a few beans just natively discovered in the class path. Right, so that's just very briefly the Spring component model in its modern incarnation. There are many, many, many things to add to this picture, but it's not the primary purpose of this presentation. However, as I've already mentioned, basically all of those things translate quite well, some of them like really well, into the Groovy world. So we are already seeing quite a few people, quite a few applications using Groovy as their language of choice, doing configuration classes in Groovy, doing standard Spring components in Groovy, doing Spring MVC controllers in particular in Groovy, so, and making use of all of those annotations. From a framework perspective, those classes all look the same to us, right? We are doing runtime introspection in terms of annotations and basically just do our usual thing against those classes. So we are not, at this point, treating Groovy classes specifically. If you happen to compile a class with Groovy and follow the Spring programming model conventions, that's just like any regular Java class to us. We're processing it like this. What we intend to do now in the Spring Framework for All generation is to go a little bit beyond that. Not radically, so we're still hanging on to that programming model, even if there are some general there's some general fine-tuning planned for the 4.0 generation in terms of their programming model, but it doesn't matter to us today. The point is, we're still taking this and considers Groovy a first-class implementation language for use with the Spring Component Model. First class means where necessary, where actually beneficial, we'd like to introduce dedicated detection of Groovy classes, automatic detection, so that some of the things that you have to do to make things work really smoothly, in particular with Spring AOP, are just smooth out of the box. For the first time in Spring's history, we'd like to basically roll dedicated Groovy support into the core framework itself in very specific places for very specific reasons. And some of those I will show to you. So it's not a radical change, but it's nevertheless an important change on our side. So the general Spring framework consists of 3 areas of work. I've mentioned 2 of them already. It actually consists of more than those, but those are the most important ones, the 3 I'd like to mention today. The Java 8 related work is a little bit forward-looking. We are primarily interested in understanding Java 8's language features and the implications of those language features against the Spring programming model. You could say the very same actually about our Groovy support, because with the first class Groovy theme here, we would like to understand a little bit better what it means to use Groovy language constructs against Spring APIs. And we're working with the Groovy team to improve the story where we can, where typical Spring conventions, in particular in the APIs, JDBC template, for example, taking like a roadmap implementation, taking callback interfaces, like a framework API, having a query call or update call or whatever, and taking a callback implementation, commonly done with anonymous inner classes. Those things can be really great candidates for both areas here. In Java 8 we have lambda expressions, and I'll show you in a second. In Groovy, of course, we have closures, each of them with specific design. They are not quite the same, but both of them very applicable to typical Spring API design. So things work at the moment. Basically, the simple version of the story here is you can talking about today already, right? Take Spring Framework 3.2, something, and just do your thing, right? However, you will have to do a few things that are not as natural as they could be. And those few things are exactly what we'd like to fine-tune. Both with Java 8, where we want dedicated support for Java 8, so Spring Framework 4.0 is not just like compatible with Java 8 at runtime, it actually means to do things in a way that makes the framework a really natural fit with Java 8 language features. And the same, of course, for Groovy here. I'll be talking about what we do with the Bean Builder and the AOP in a minute, but that's the big picture behind those things. As a kind of side note for today's presentation, we are also working on a WebSocket endpoint model and on a few other things, but I do think that this one is pretty important. This is not just Spring MVC being able to do a WebSocket in some corner of the framework. It is a dedicated WebSocket endpoint model along the lines of what we're seeing in other frameworks and other languages, somewhat close to the standard server container world still. We have JSR 356 alignment. 356 is the WebSocket JSR. That's basically a kind of servlet extension. It's the server container way of supporting WebSockets. And of course, if we are running on Tomcat 8 or any other such container, we would like to make good use of those built-in WebSocket capabilities. But otherwise, it's a quite independent endpoint model for WebSocket-style applications, WebSocket-style backends. And there's quite a lot that we're trying to roll in here It's not just raw WebSockets. We have very dedicated SockJS support. This stuff, the WebSocket stuff, has seen its initial release in 4.0.1 this week. So some of that can already be checked out. And it's probably going to be feature complete for M2 in July. All right, so those are really a selection of three important areas that we're working on for Spring Framework 4. There is, of course, a lot of side work. I'll also just be mentioning that there's a whole bunch of specifications that we're upgrading to. So just in general, if you're considering an upgrade to Spring Framework 4.0, keep in mind that it's not just Spring itself moving on. There's a lot of other stuff moving on. And Spring Framework 4.0 introduces dedicated support for all of those things, some of them very common, right? Java Persistence API, JPA, beam validation. One of the actually most popular ones lately. We get quite a bit of feedback on our beam validation support. A few important pieces that are just important for proper middleware integration, where new capabilities come along. For the first time in the EE's history, in Java EE's history, we get standard access to server-managed thread pools. That's what JSON 236 is about, simply speaking. So there are quite a few interesting things in here that we are picking up in Spring Framework 4.0. Maybe in terms of the programming model, because that's what we're talking about primarily, this one may be interesting. There's a standard transactional annotation now in JTA, independent from EGB. Similar to EGB transaction attribute, but independent and defined by JTA 1.2. We already ship support for that one. That's a great fit for the Spring programming model, because in the Spring programming model, we combine support for standard annotations with some specific annotations in the Spring world. And I haven't been mentioning here, but even here you see a mix. That's a Spring stereotype, that's a standard JSON 330 injection annotation. That may be Spring's transaction annotation, or it may be JTA's. I'm not saying here, it could be both. And so that's actually what we want it to be like. Not talk about some specific annotations being standard or not. It just needs to be a coherent overall picture. And we do believe that the way that we are doing our own annotations and how we handle them next to the standard annotations really makes the picture very sound and hopefully natural to use in combination. All right, so some of those things are moving on. If you upgrade any provider to that level here, so if you're trying to use Hibernate 4.3 or higher, which is in beta at the moment, or Hibernate Validated 5.0, so if you're trying to upgrade to an external piece of middleware that's compliant with any of those new versions, please use Spring Framework 4.0 with them. That's where we have dedicated support. In earlier generations of Spring, it may work, but it's not actually officially supported to use any of those newer specs with Spring Framework 3.x. Since I'm getting the question every time, I'd like to just give you the JDK ranges. In particular, look at the lower two, right? In Spring Framework 3.2, we have explicit Java 7 support. We're building with OpenJDK 7. We do everything the JDK 7 way, but we retain compatibility back to JDK 5 still. In Spring Framework 4.0, we just bump it up a little and require JDK 6 now, which is, even JDK 6 is kind of officially end of life by Oracle now, so even that is a historic concession. But we are seeing so much need for JDK 6 still, so much use of JDK 6, so many platforms that have a hard-coded JDK 6 arrangement underneath their servers, that we're not raising the bar further than JDK 6 at the moment. And we do introduce dedicated JDK 8 support. Just keep in mind, it's not all JDK 8 based, even if that's what we're talking about. And the same in the EE version ranges. In 3.2, the third one, we basically at Java EE 6 level, that's JPA 2.0, basically 4 years ago, what the Java EE produced 4 years ago. That's our baseline. And we have historic support even back to J2E 1.4, which is deprecated, but nobody notices. But we do support Java E5 service in particular, standard Java E5 service. Spring 4.0, we are bumping it up to E7, and the minimum is going to be a Java E5 plus server. In all fairness, we would like to raise the bar to Java E6 plus, Server 3.0 plus, JPA 2.0 plus, and partially we do that. We do raise to JPA 2.0 plus, but we do retain compatibility with Server 2.5 for the time being. There are just a few important servers and cloud platforms out there that are still on Server 2.5. So that's the way that we handle our supported version ranges for platforms underneath. It's quite a straightforward approach over the years, so I just like to put a stake into the ground. Handling those shouldn't come as a surprise to anyone. I don't expect basically that to be a problem in upgrading to Spring Framework 4.0, right? If you're upgrading to Spring 4.0, we expect you to use JDK 6. Actually, we expect you to use JDK 7 in practice, and we expect you to use at least Java E6 compliant deployment environments when using those. All right, let's get over that part and talk just a little bit about Java 8. Because Java 8 is actually quite important, and it's not just important for its language features, it's important for its API features, it's important for some of its runtime features. Basically, the JDK or the JVM in its 1.8 level does quite a few things differently. Heap management, for example. So quite a few things, quite a few characteristics of JDK 8, of the JVM in the JDK generation, are important enough to justify an upgrade even just for those. Even if you're not using any language features, and even if you're not using any of the new APIs, you might still want to upgrade to JDK 8 once it goes generally available, simply because runtime enhancements. And that applies to Groovy-based applications very, very much so. Not least of it all because of enhanced invoked dynamic support and so forth. But let's go back to Java 8 language features for a second. I'd like to show you what they look like, because they're quite interesting stylistically, next to like if you keep like a Groovy style in mind, they are an interesting reference point. We do have IDE support if you'd like to play with it, just to get familiar with it. I recommend IntelliJ IDEA. Ever since 12, now with 12.1, it actually has quite great JDK 8 support. Almost everything I tried just worked out of the box, and that came as a surprise. I didn't expect that to work out. With Eclipse, of course in Eclipse, like they always do, they plan for language feature support. I think the first time they're officially going to release it is like March next year. That's when OpenJDK 8 has its target date now, because of ongoing delays. So that's when Eclipse wants to have its stuff ready. We're trying to do it a little bit earlier in our Eclipse based stuff, but I'm not sure whether that's going to be possible, right? I mean, with Eclipse, we really have to do things properly the Eclipse way. We can just release early plugins, basically, building on third-party plugins that aren't quite final yet. Now, next to those, we intend to go GA with Spring Framework 4.0 in October. That's particularly noticeable because it is before the OpenJDK GA date, right? That wasn't quite planned like that. In the original plan, we meant to wait on OpenJDK 8 because it was supposed to go final in September. Doesn't do so now, has been pushed out to next year. We still intend to go GA in October, maybe early November, definitely in Q4, with Spring Framework 4.0, and we'll ship best effort Java 8 and JVM 8 support the best we can, basically. And Grails 3.0 will build on this, or very likely actually on 4.1. by mid next year when Grails 3.0 goes out. Initial Grails 3.0 milestones may be built on Spring Framework 4.0. So this is really the state of affairs. A new JDK version is really important to us. So we are not going to drop OpenJDK 8 support here, even if it gets delayed. It's too important. And we do want to do that work early. Our entire test suite, our entire build runs on Java 8 now. Even that was quite an exercise. And when we have like an extensive test suite, testing so many things and so many third-party pieces, including actually Groovy, we test so many things that we had breakages in many places. So even turning the test suite into a properly running test suite on OpenJDK 8 was quite an effort, but worth it since we actually learned a few things along the way. So one thing I'd like to specifically point out is GSR 3.10, because this is, well, it's going to have some effect, Groovy experience, I'm sure. But GSR 3.10, just generally speaking, is the first time we are seeing a new approach towards date and time value types in Java, right? We have Java util calendar and Java util date. In standard Java, we never really got anything else. We do have Joda time as a kind of external project that really does things quite differently. But in standard Java, we haven't seen any of this. Actually, those times, those value types are the same of the same name in Joda time. But we get same named value types in JDK 8 now, in the JavaX.time, in the Java.time package. So local date and local date time, those, just as two examples, those value types can express a very specific kind of date or time type. It's not just a Java util date that may be anything, right, from a timestamp to a specific day to a specific day plus local time. It doesn't really say so. With those expressive value types, we get properly expressed basically date and value meanings in our domain model. We're talking about the heart of the domain model. How do we represent specific kinds of data types, date and time types in this case, in our domain model? As of Java 8, this is the way for Java, for date and time types. GSR 3.10 as a replacement of the 15-year-old or more than 15-year-old Java util date and calendar types. In Spring, we actually have support for Joda time. We're already for 4 years now since 3.0, and I'm sure some of you have run into it or used it. The stuff that we're doing now is very similar, of course. We support the date-time format annotations. We support binding to those value types. We support rendering them out as strings with predefined formatting rules. What you can see here is the way that Spring handles those, right? It's an annotation, a field level annotation called datetime format. That's in the standard Spring programming model already for more than 4 years, the way of suggesting standard date and time string formats for binding and for formatting. And we translate the existing support to Java 8's new date and time types here. So that's in a Spring-based domain model or any kind of value object model. That's the way to handle those things. It can be overwritten externally, just as a side note, but if there is no explicit metadata on how to render those out or how to bind them, then the framework looks and format annotations at the field level and basically uses it as a default. And there are quite a few ways to express the default, as you can see here. Like there's an you can refer to ISO standard formats, or you can do patterns, or quite a few ways. So that's GSR 3.10. It's not the only interesting API in Java 8. There are quite a few. So there's more than this in terms of new APIs in Java 8. But this may be the highest impact, because it's just about something that we need to do in the heart of the domain model. So any JDK 8-based application, I'm sure, will be using those. If you're actually JDK 8-based, if you can rely on the presence of JDK8. The other interesting part about Java 8, of course, is the language features. And as promised, I'm going to show you a few examples of what this looks like against Spring APIs. That's just a few Spring APIs that are typically being used with, or whatever you want to call them. In Java 8, they are now called interfaces. They used to be called single abstract method types, just for the sake of including abstract classes with a single abstract method. But in Spring, we don't use many abstract classes. It's primarily interface-based. Basically, some Spring API doing a method invocation, passing in an implementation of the callback interface. That's with JDBC template, 3 different interfaces that allow you to process the result set in different ways. JMS is a good example, creation of JMS messages, setting of JMS message headers in the post processor. Those things are all callbacks. And task executor, which is like, or async task executor, which is, and task scheduler, which are like Spring's interfaces, abstractions for asynchronous processing for like thread pool. Runnable and callable are, of course, typical examples, right? Runnable with a single run method, callable with a call method. If you're taking this quite far, if you're doing a lot of JDBC template processing, a lot of JMS template handling, or a lot of little async processing units, what you're going to see in your code is like, in standard Java code, is like tons of anonymous inner classes, right? With plenty of method signatures and that overrides on those method signatures, just messing up your method bodies. In Java 8, with lambdas, for the first time in the Java language's own history, there is a concise way to represent such callbacks. I mean, look at this. This one line here is a prepared statement setter in Spring terminology. Basically an interface where you get the prepared statement and your implementation can set any stuff on that prepared statement. This is a really concise way to express those things. No method signatures, just the parameter name and a little lambda expression allowing you to actually do something against that parameter. I'm not even going to show you the anonymous inner class here because it wouldn't fit on the screen. Not with all, in particular, not with this screen size here, not properly. There's the second one. So there you see 2 lines, 2 lambdas here. This one down here is a row mapper. And the row mapper gets a result set and the current row number. This is basically the parameter reference that you see before the actual expression. And this uses expression. It basically has an implicit return. Right? It says new person, operate against that result set, do your thing. It's being returned from that row mapper. Granted, from a Groovy perspective, this doesn't look like anything that exciting, right? It's not like, okay, yeah, well. But with this is valid standard Java 8 language, basically, as usable in source 1.8 Java files. And in that sense, it actually is quite a step. And actually somewhat different from Groovy closures. Look at the syntax with that parameter prefix here, where you basically enumerate the parameter names, usually not the types. You can add the type declarations here, but you don't have to. I mean, isn't that unusual for Java to allow you to drop static type declarations? Right. So those things really move closer to Groovy ways of doing things. It's not going very far. What I'm showing you here is it, right? That's the Java 8 language features. Here you see that shortcut arrangement, as I've been showing you up here. Here's just a slightly different version, where you would form it. It looks a little bit more like anonymous inner classes now. You may prefer that formatting. Some Java people may prefer that formatting, and an explicit return statement down here. It's really just a variation of the above. with this is it, I actually include this slide. As a variation of this, we also get method references. So we get lambdas. This is language feature number 1. And the second language feature in Java 8 that's worth looking at is this one here. It's a method reference. This is actually, it is basically a lambda itself. You can only use it in the same places that you can use lambda expressions. So pass it into some API that accepts a function of K compiler will basically turn this thing into an implementation of your interface. Just like here, just like it takes this thing and automatically coerces it to a prepared statement header, and it takes this thing or this thing down here and automatically coerces it into a row map implementation. Exactly the same thing happens here. This little method reference takes basically this method that it points to, takes this method and basically coerces it into a row mapper, into the thing that it is being passed into here, into that query method, which expects a row mapper parameter. So keep in mind those features are really limited. Those guys don't really do much. There is no independent representation of a method reference, for example. There is no representing a lambda expression. It's a pure source level feature. It's something that compiler swallows and turns into an arrangement in bytecode at the time. But it is stylistically interesting. Of course, with method references, it's not so far from Groovy in the first place. This stuff is somewhat interesting in how it allows you to refer to parameters, or how it uses those parameters to select between overloaded methods. So there are a few implications of this that don't directly map to Groovy. Anyway, this stuff works with Spring Framework for ON1 against, it actually works, it would work before as well in some arrangements anyway, but in particular with for ON1 it's like officially supported with the use of source 1A Java files against Spring APIs. Now, I've already mentioned those guys actually somewhat restricted typical Java style language constructs with a little to no representation at runtime and completely static in a way that they are being handled by the compiler. So they're not really anything equivalent to what Groovy does in that sense. Stylistically, of course, they are quite interesting, and I mean, I find them attractive. They are concise enough, and I mean, that parameter clause can be a little silly if there are no parameters in your callback, but because you have empty brackets, then you do have to have them. But it's for Java, it's actually quite a step that they take. Let's switch perspective. From a Groovy perspective, it would be nice if there was some kind of alignment with lambdas. In combination with Spring, it would be nice if at least Groovy closures worked equally well and equally concise against Spring APIs. And we're close, but not 100% there at the moment. The whole Groovy closure model, of course, is much richer, right? But it has a few assumptions in it. Coercion always requires an S clause, right? So you can't really do it like this, where you're just passing the thing in and the compiler figures out that this needs to be a row map and this needs to be a prepared statement set, which is not being specified anywhere here, right? In Groovy, you basically have to say, I'm passing this in, I'm coercing it to a prepared statement setter, a row mapper. And some of this is actually being fed back to Groovy itself, right? You're going to see improvements in Groovy itself that kind of get it a little bit closer to, well, the Java 8 Lambda experience against Spring APIs, against the use case that is being represented by typical Spring APIs. So this is actually ongoing work, remember, work in progress. We are discussing this stuff right now. I'm not going to claim that this is actually going to happen in those two, but the state of the discussion, as we had it on Tuesday, this is basically what we ended up planning for. where we would like to have a Groovy, basically a mechanism in Groovy that's smart enough to figure out the ask clause itself if we're working against a unique type anyway. If we are clearly passing a closure into an API with non-overloaded methods where it's clear which argument it is being coerced to, then the ask clause shouldn't be necessary. It would be nice if Groovy itself, and in Groovy 2.2 that may happen as planned, if we could figure out the type directly. A bit like with Java 8 lambdas. And this is actually stuff that the Groovy guys have been raising, the Groovy team themselves have been raising. Things may be even going a bit further. We're talking about next year now, right? There may be some alignment where lambdas kind of have a representation in the Groovy language, maybe slightly different in semantics from Groovy closures. And there were a few interoperability questions, like can you pass a lambda expression in Java, a Java-style lambda expression against a Groovy API that accepts a closure argument? Is that even necessary? For Spring's purposes, this is really all that matters. We would like Groovy closures to have basically the same nice experience in combination with Spring APIs that Java 8 lambdas have. And a default ask clause for simple scenarios would be a great step here. So keep in mind, work in progress, things may change, things may not work out as planned, but this is at least an intention at the moment. So let's move on a little. This is a Groovy-based bean definition as called bean builder in Grails, right? This is basically the Grails way of kind of sort of mimicking a Spring XML bean definition in structure and even in style. But that's actually a quite cool feature in its own right. It's a style that has been popular, not only with Grails. We had feedback from quite a lot of people just liking that style of defining beans. Keep in mind, configuration classes, we kind of have our ways of doing those things with annotated methods, which of course translates to, can be done with Groovy-based configuration classes. However, this is slightly different. Those are externalized bean definitions, more similar to XML bean definitions than to configuration classes. And for that purpose, externalized definitions, where you're defining instances of bean classes that are maybe not under your control, right? Like basically this was here, externally provided classes that you're configuring. A very typical task in Spring middleware setup. And in particular for those kinds of things, this is a really nice style. Of course, nothing new, because Grails has been doing that for years now. The idea is to take what Grails has, to revise the APIs behind it, right? To turn it into more of a Spring Framework core affair in terms of how it is being handled, how it is being processed at runtime. At the same time, Grails 3.0 would be picking it up and including it basically as a Spring Framework feature, but linking it into the Grails world with the user experience for Grails users not being much different than before. Ideally even completely the same. But that feature all of a sudden being available as part of the Spring Framework distribution. Any standard user of the Spring Beans module, or at least the Spring Context module that has to be determined, would be able, probably the context module, would have to be able to, would be able to use that format, right? Would just have to include Groovy in their Maven pumps and can start using that feature because it's in the very core Spring jars as an alternative to XML bean definitions. We basically want to make it available at the same level as first class any other external bean definition format that we have. We don't have many anyway, XML and property files bean definitions. Those are the only external ones. And this is basically actually the nicest variant that we are aware of. So we'd like to turn that into an equally first-class feature. Next to our annotation-based scanning and the configuration class model, this turns into a really complete, really modern configuration experience. In Spring style, of course, you choose which format you're using. It's your choice. Spring has always been a kind of toolbox, right? Choose your format. And this is really in that spirit. It's a format that will be supporting out of the box. It will be part of the reference documentation. It will be used in a sample application or two. And we just hope that as many people as possible notice the availability of those things, right? We want to make Groovy-related, Groovy-based features as available as other core Spring features to the same audience, as easily linked in your main pumps, basically. We want to open it up to a new audience, an audience that may have liked what they saw, but they may have been unable to use it because it's like in the Grails distribution and a little odd to use it from there if you're not building a Grails application. So we're basically taking it and making it available to a broader audience through inclusion in Spring Framework itself. I've been referring to the AOP tree. Just a few words here. The stuff that's been mentioned on this slide, at least in the upper part, has been done by Grails already, right? Grails has always been setting up Spring's AOP framework in a way where it has special detection for Groovy object and excludes a few methods that are definitely not to be proxied by Spring, because they are not user-provided, they are compiler-generated. The idea behind this is that we roll those features, those exclusion rules, that special handling of Groovy classes into Spring Framework proper, so that in Spring Framework itself will be automatically detecting that we are actually trying to proxy a Groovy class here, and that some rules, some exclusion rules in particular, automatically apply for those kinds of classes. We are willing to do it in a form where Groovy has first class support in Spring itself, where it's basically an if clause that says if Groovy then in relevant Spring classes. Grails, of course, can then just build on it, right? It would just not have to do its adaptation anymore. It would just use what Spring Framework does the standard way. This is going a little bit beyond that. That's something more experimental, where we're trying to explore Groovy AST transformations and trying to do some post-processing that Spring usually does with proxies or with load-time wheeling, to do those things the Groovy way, to use AST transformations to kind of set a transaction interceptor, apply a transaction interceptor to a target class, to a target bean. We can do this. It has been prototyped, but we don't quite know how it's going to work out in the wider context. So I can't promise that this will make Spring Framework 4.0, but this is about more advanced stuff, where if you're using a 100% Groovy-based application, if all your application classes are Groovy-based, this might be a really nice way to do like transaction handling, cache handling, not using proxies like Spring always does, but using AST transformations, because you know that all your Groovy classes would generally support AST transformations anyway. If you're using a mix of Java classes and Groovy classes, well, maybe you would want to do something like this, but of course your Java classes need to do proxies then, and your Groovy classes would be processed differently. I don't find it so compelling for a mix of languages, but if it's 100% Groovy based. All right, since we're running towards the end of the time slot here, so I guess already summarizing a bit here, the whole point of this exercise of this plan is we'd like to support Groovy as a first-class language of choice for Spring-based application architectures, which means taking the Spring programming and configuration model, as mentioned, using it with Groovy, literally doing things the way you would do them with Spring and standard Java, just replacing every single .java file that you have with a .groovy file. And just basically work that way, right? Everything else applies. All the standard Spring setup rules, all the Spring conventions, the ways of tapping into middleware, the configuration styles, the use of annotations, everything applies. You're just using a different language of choice for your application source files. And well, as a side note, Groovy 2 static compilation mode is somewhat interesting for our purposes here. Maybe not for people like yourselves with a lot of Groovy background anyway. Keep in mind that we're doing quite a few of those things, in particular in order to attract a more traditionally minded Java audience and to kind of warm them up towards Groovy, to like lower the barrier and on-ramp them in terms of using some Groovy. And of course, for those purposes, features like typecheck or compile static could be quite interesting. We're definitely going to mention them prominently. That if anyone's concerned, about the different semantics with dynamic typing and so forth, and they, for a larger team, where like the team lead or the architect would really like to have a bit of a tighter, check it for his developers, that might be a good fit. All right, that is really it. You can see the release plan. I've mentioned it before. Particularly, this part is interesting, of course. In 4.0.2 in July, we do intend to ship basically what I've been talking about. Big question mark behind the AST transformations, but otherwise everything that I've been talking about here will be shipped in M2. So give it a try once it's available, and let us know whether it works for you. And if you have anything else that you'd like us to do, if you're working with that kind of model and you ran into any kind of gotchas, if we can smoothen the experience, your experience with using Groovy on or within a traditional Spring Framework context, please let us know this is the right time to talk about this. Thank you. And if there are any questions, just come up right on. Or can we take them here? Whatever way.